Hi, I'm Tirmazi, and I want to just give you an overview of what we discuss in our talk and our paper, Borg the Next Generation. Borg handles most of Google Cloud's workload, and it is a very old and robust system. As part of this paper, we're releasing a set of Google Borg traces, which basically give you an idea of what Google's workload looks like and allow you to do exciting research using it. We also shared some reasonably extensive analysis on how Google's workload has changed over time from 2011 till now. And the idea behind that is to give you some sort of appreciation for the challenges that need to be solved to create a cluster manager that can work efficiently at Google scale. Here is a bit of a sneak peek into all the exciting ideas and observations that we reveal through our analysis. What is Google Borg? Well, Borg is basically Google's internal cluster manager, which is used to schedule jobs and tasks and all of these things which I'll describe later. I mentioned how we're releasing public traces as part of this project. What are Borg traces? Borg traces describe the workload in a Borg cell. So this includes the arrivals and departures of jobs, allocs, etc., and the scheduling decisions Borg takes on them, including evicting them or assigning them to machines, etc. Similarly, it also includes a measure of how much resources Borg allocates to each task and how much of those resources the task uses. So what's new about this updated set of Borg traces we've released? To begin with, we're releasing a lot more cells than the 2011 version. So now we have 8 cells over the month of May 2019. We are now reporting CPU usage histograms instead of just the average usage by a particular task in a particular time period. Now what this means is that you can go and look at the instantaneous distributions of CPU usage among tasks. This recent trace has information on how jobs use this thing called autopilot, which tries to predict the resource usage of jobs. Here is the big takeaway message from all of that analysis. I've shown you both of these plots earlier. So the plot on the left is the resources used by jobs, both for the 8 cells in 2019 and the 1 cell in 2011, which is all the way to the left. Take a close look at the 100% capacity line that is spread across the middle of both of these two plots. So if you notice from the allocation plot, Borg is oversubscribing a lot more aggressively in 2019 as compared to 2011. However, if you look at the resources used by jobs from the plot on the left, you'll see that jobs are still not reaching the capacity of the cell. In other words, jobs really do ask for more resources than they use. One of the most mind-blowing observations we've had during our analysis of the trace is with regards to its variability. So for variability, we're using this metric called c-squared, which is the ratio between the variance and the mean squared for CPU hours or memory hours or whatever other metric you want to measure. For 2019 though, the c-squared recorded becomes larger than 23,000. This is the largest c-squared value recorded for any published cluster trace, and it has really big implications for scheduling and cluster management. Prior work has shown this to be as high as 50%, but at Google, we see that in 2011, it was over 97%, and in 2019, it was over 99%.